Revelator John.
Hello Revelators, welcome to Revelator John. Today we're talking more on aviation theory and how does a helicopter fly? So a question that a helicopter pilot will get asked periodically, especially if they come into contact with members of the public. How does a helicopter fly? And as pilots, you'd want to give a very expanded and elaborate explanation of how indeed a helicopter flies, but invariably you just don't have the time to do so. So to explain that process, you'll obviously take many hours and go into all the intricacies of aerodynamics, so on and so forth. But in very, very basic terms, this is how a helicopter flies. So I have a model with me here, a nice little Lego model, and this is a very simple model of a helicopter. It's just a two-bladed helicopter main rotor, and it also has a tail rotor at the bottom, so at the back. So the main rotor, as the blades spin around, they create what we call a rotor disc. Okay, so the rotor disc can be tilted by the flight controls inside the helicopter, can be tilted in any direction, okay, to make the helicopter move. So if the rotor disc is kept parallel with the surface, then by applying what we call the collective, okay, which is it looks like a handbrake in the helicopter, we raise that up. That increases the blade pitch as they're spinning around, so they generate more lift. So, and they all do that at exactly the same time. Okay, so what will happen is that we keep the disc level, raise the collective, increase the pitch, increase the lift, then all the blades create more lift and the helicopter will climb. If you lower that collective lever, the blades twist down, lose lift, and they'll start to descend. So you do that in a controlled manner. Okay, if we want to actually move the helicopter in a certain direction, fly it forward, side, left, right, backwards, okay, there is another control called the cyclic, and you hold that in your right hand, and it looks like a joystick, a big joystick. And what that does, that changes the pitch of the blade and increases or decreases the lift generated by that blade at a particular point in its rotation. So let's say, for example, if I want to make the helicopter fly forward, I need to tilt the rotor disc forward so that I'm propelled forward. Okay, the way this has done that, okay, this blade that is moving forward, at its 3 o'clock position, we want to go in that direction, forward. I push the cyclic forward, the joystick forward. This reduces the pitch on this blade. It will start to lose lift. So eventually, it'll end at a low point here over the nose. At the same time, this blade here, at the 9 o'clock position, will increase its pitch and increase the lift generated, and it will reach a high point. The net result is that the blade over the nose is low, the blade over the tail is high, so the net result is the disc tilts like that, and so you will move forward. Whichever direction you move the cyclic will tilt the disc, left, right, forward, backwards, and that's how you move the helicopter. So movement of the helicopter, how it's flown, is controlled by the cyclic. How we maintain altitude, climb up and down, and also maintain altitude when we're flying around, okay, that is done with the collective. The tail rotor here, this has another little mini rotor, if we look on here, there. Okay, so when the helicopter is in hover, if the blades want to turn this way, then the fuselage will want to turn the other way. Okay, so we have to counteract that anti-torque. This anti-torque rotor, we have to counteract that torque effect. So this mini rotor is exactly the same, has the same effect as this main rotor here. And we control the pitch on the blades here, the amount of lift that is generated, but the lift we're pointing sideways, and we control those by pedals. Okay, so the net result is, if we want the helicopter in a hover to turn to the right, we push the right pedal. If we want to turn it to the left, we turn the left pedal. And by increasing or decreasing the pedal movement, by pushing and pulling on the pedals, for want of a better word, we increase and decrease the pitch on the blades, on the tail rotor, and that increases and decreases the lift going sideways, so it will push the tail left or right so we can keep the nose straight of the aircraft. So that's how basically a helicopter flies. The cyclic tilts the disc in the direction of travel, so it pulls us along. The collective makes us go up and down and keeps us at a certain height, or keeps us at a controlled height or controlled flight profile. The tail rotor is controlled by the pedals and the foot pedals, and that will make the helicopter go left or right in a hover. Now, in forward flight, the helicopter is designed to be aerodynamic. Okay, so you'll have a higher speed, the tail rotor becomes less and less effective, and you have this vertical fin here on lots of different designs, of course, that will create some longitudinal stability. Okay, so we'll be able to fly through the air. It might also have some horizontal wings coming out here and out here, and those are what we call horizontal stabilizers or stabilizers, and they will provide some stability in what we call the pitch attitude. Okay, so it will be able to fly straight. So the vertical stabilizer, the vertical fin, creates a bit of longitudinal stability, and these horizontal stabilizers control a bit of lateral stability. Okay, so the helicopter in itself is very unstable. Okay, the pilot is constantly having to make inputs into the controls to achieve the desired effect. Okay, it is an unstable aircraft, or it's inherently unstable, hence why the constant manipulation of the controls. The cyclic for tilt the disc, the collective to maintain a level, go up or down, and the tail rotor to control in a hover. The vertical stabilizer or vertical fin and the horizontal stabilizers at higher speed maintain stability, and you can fine tune that stability just by adding a bit of pressure to the pedals to increase or decrease the lift on the tail rotor in a sideways motion. Okay, so hopefully that explains how a helicopter flies. Obviously there's a lot more involved than that, but essentially that is how the controls work and what those controls affect on the helicopter, and then how the helicopter flies, or how the helicopter responds to those changes to the main rotor and also the tail rotor. Okay, thank you.